Hey there, pre-calc friends. Today we're going to talk about a really important formula called the law of sines. And the reason we need to know this formula is because up to this point, you've been playing with triangles that are specifically right triangles with that right angle. Whenever you have right triangles, you can do beautiful things. Like once you have a theta, you have an opposite side, you have an adjacent side, and you have a hypotenuse. And because you have all those things in a right triangle, you can do great things like SOHCAHTOA because you have opposite, hypotenuse, adjacent, hypotenuse, opposite, and adjacent. And that happens only in right triangles, only because there is that right angle. But unfortunately, in the real world, not everything is made up of right triangles. Like example over here, look at these triangles. They're definitely not right triangles because I can't see a right angle. But what if we still really need to solve them? I need to solve these triangles, mean I need to find all the sides and all the angles. That's six things, right? Three sides and three angles. How do I do it if there's no right angle? How can I do it without SOHCAHTOA? And that's where our awesome law of sines comes in. It's going to help us find all angles and all sides of a non-right triangle. All right, here's your formula. Let's write this down. The law of sines says this. In these triangles that you see here, just first of all, notice that the larger uppercase letters are the angles, and the smaller ones are the sides. But notice specifically where we place each of these. Do you notice how the upper and lowercase are always across from each other? That's on purpose. So angle B is always across from side B, angle C is always across from side C, and A as well. So we always do that on purpose. So here's what the law of sines formula says. It says, if you take the sine of angle A, that's capital A, right? And we divide it by the length of side A. That fraction, that ratio is the same thing as taking the sine of angle B and divide by the length of side B, which is also equal to, I bet you can guess it, the sine of angle C divided by the length of side C. That's what the law of sine says. It says that each of these ratios are equal to each other in these types of triangles down there. Now, does it work for a right triangle? Oh, definitely. Of course it does. It's much easier with a right triangle, but we just tend to use SOHCAHTOA instead. But if you have a triangle like you see down here and you don't have a right angle, you can't do SOHCAHTOA. So we need to use the law of sines here to figure it out. Now, when can we actually use the law of sines? Really depends on what the triangle case is. For example, what if I give you a triangle and I give you two sides, for example? I'm sorry, I'm saying two angles. So how about I erase that? Let's try that again, Mr. Brown. What if I give you two angles? How about angle A and angle C? And I give you one of the lowercase sides. For example, maybe, how about this one? If you see this, this is, do you remember? This is called angle, angle, side from our geometry days. Angle and angle, and the side is not included in between. So that's called angle, angle, side. If you see angle, angle, side, you should use the law of sines. Okay, how about over here on the right side? What if I give you angle, angle, and I give you this side? Do you see how that side is actually in between the two angles? We call that angle, side angle from geometry. If you have a triangle that is given angle, side angle, you will use the law of sines. And one more case that we have to focus on. That's if we have two sides and one angle that's not included, not in between. I mean this. How about this side and this side, and not the angle in between, not that one, but maybe this angle over here. That would be called side, side angle. And that's a very unusual case. I'll put a little star because it's very unusual. Why? It's called the ambiguous case. If I give you two sides and one angle, well, a lot of things could happen. First of all, well, maybe you solve it and you get one triangle. Yay, that's all great. But maybe by chance, the triangle doesn't exist. Maybe the sides don't match. Maybe they don't line up and actually make a triangle. It's possible to get no triangle based on given two sides and one angle. Or maybe because of a very unusual case that we'll see later, it's possible to solve these and get actually two different triangles back out. So we call this the very strange ambiguous case with the law of sines, and it only happens if you have side angle. But for that will be for a different video. For today, let's just focus on the normal angle side types of law of sines and an angle side angle type of law of sines. Okay, let's give it a try. So there's your formula. Let's give it a shot. Here's a great example. You're given some really interesting info about angles and sides, and the instructions say solve the triangle. And that means you need to find all 6 things, sides and angles. So you need to find 6 things, all 3 sides and all 3 angles. And that's called solving a triangle. Now, first thing we need to do is we need to figure out, well, is this going to be a law of sines or is it a different law? Obviously, we're in the law of sines section, so it's going to be law of sines, but it's good to check now. So the first thing we do is let's just make a little sketch of the triangle. All right, so I'm just going to do a really basic triangle here. I'm purposely trying not to make it a right triangle. And remember, we put the uppercase letters as angles. And across from those, I put the lowercase letters for the sides. There we go. That's generally how we're going to draw all of these triangle ABCs. Now look what they gave us. They said that angle B is 30 degrees. So I have an angle B. I'll just circle that. I have an angle C of 45. Okay, got that. And then they gave us a side B of 9. So side B. All right, let's figure out what case is this. I have an angle, I have an angle, and I have another side. And that side is not in between. So this is considered an angle, side. Angle, side. Good. It's not the strange ambiguous case, so we're good to go. We can just proceed as planned. But we would definitely use the LOS, the law of sines here. All right, so after we made a sketch and we figured out what case it is and what law we need to use, we need to organize ourselves. So here we go, folks. Let's make a cute little answer box here. In the answer box, I'm going to put all 6 things I'm looking for. Angle A, angle B, angle C. And over here, how about side A, side B, and side C? It's just a great way to organize all of your answers as you put things together. All right, so for every problem, I always make a little answer box so I can see where everything lines up. All right, now they gave us some stuff, right? So why don't we fill in some things? They already gave us angle B is 30 degrees. That's our capital letter B. We have angle C is 45 degrees, capital letter C. And side B over here is 9. So that means I need to find angle A, and side C, and then I'll be all done. All right, well, let's actually give it a shot. Now, the interesting thing is before you even try any kind of law of sines, can you just see that using a little bit of knowledge from geometry, can we just find angle A right now? Remember, in a triangle, all 3 angles have to add to make 180 degrees. So if I already have 45 and 30, I can subtract from 180, and I would find out that my third angle A would be about 105 degrees. Yay, that's done because 105 plus 30 plus 45 is 180 degrees. Good, okay, without even using the law of sines, I've got my angle, I'm good to go. Now what we need to do is either solve for side A or solve side C. It's up to you. I'm just going to do side A first since it's alphabetical. So here's how we're going to use our cool law. Let me remind you what that law is. All right, let me erase my triangles so I have a little more room for you folks. All right, remember the law is sine of angle A over side A is equal to the sine of angle B over side B equals the sine of angle C over side C. Now, this is really unusual and kind of uncomfortable to look at because there are 1, 2, 3 fractions. We rarely see 3 fractions and 2 equal signs in math. It's usually 1 equal sign and a fraction equals another fraction, not like 2 or 3 of them. This is weird. So what we need to do is we need to take these 3 fractions and just pick any 2 that you want to use. Maybe these 2, or these 2. Well, how do you find out? Well, let's look and see. What do we have in our answer box so far of the given stuff? Well, we have angle B, so I'll put check mark. I've got angle B, that was 30. I've got angle C. I now have angle A, and we were also given side B. So if you look at all the letters here, do you see that this middle fraction is perfect because I have both values of angle B and side B. So I'm definitely going to use that one. And then over here on the left side, because I'm looking for side A and I'm given angle A, I'm going to use that fraction too. So I'm going to choose these 2 fractions to play with to start our law of sines game. All right, so we have sine of A, and A here was 105 degrees divided by the mystery A that we're looking for equals the sine of angle B, which is 30 degrees, divided by side B, which is 9. Great, okay. So you can see that we have numbers for everything except for A, which is what we're looking for. That's our one variable. All right, if you remember in your algebra days, anytime you have a fraction equal to a fraction, the best way to solve is by cross multiplying or diagonal multiplying, where one diagonal, if you multiply, is equal to the other diagonal multiplied. So it's going to look like this. I have 9 times the sine of 105 degrees, that's one diagonal, is equal to the other diagonal. That's the side A that we're looking for times the sine of 30. There we go. In general, when you do law of sines, the first big step is cross multiply. So feel free to put that in your notes because that's where we always start with law of sines. You cross multiply. And one diagonal is equal to the other diagonal. Okay, great. Well, I'm still looking for side A, but if you notice, side A is being multiplied by this term right here. And 30 degrees is just an angle, so the sine of 30 is just a number. So in order to get A by itself, we just need to divide by that blue number there. So we're going to literally divide both sides by sine of 30. That'll get our side A free. So divide this side. And you notice I'm not using calculator yet. I'm a little worried about putting these into the calculator too early because I might round too early and then my final answer will be way rounded. So let's see if we can just solve for A first and then we can put everything into the calculator. All right, I'm going to move this over to the right hand side. Once the sine 30 is divided from both sides, that's gone on the right. And I basically get side A, which is what I'm looking for, is equal to 9 times sine of 105 degrees divided by the sine of 30 degrees. Now we can put that in the calculator. And if I put that expression, and literally you can just type it exactly like you see it. It is sine of 105 times 9 and divided by the sine of 30. Okay, when I put that in, let's see what I get. Typing, typing, typing. And it looks like I get, all right, looks like side A is equal to about 17.4 when I round. And generally we round these to just one decimal place is fine. All right, well, let me put that in there. I'm gonna put over here on the right side, I got about 17.4 for side A. Now, when we're all done, I'll show you a really cool geometric way that we can check and see if our answers are probably on the right track. Good. All right. So we got angle A, check. Side A, check. Side C. All right. So here's your bonus question of the day. Can we do this, folks? Now that I have side A and side B, can I just do Pythagorean? Can I just do a little A squared plus B squared and see if I can find C squared so I can get that really easy? No, you can't. And remember, the reason we can't do that is because this is not a right triangle. And we can only do Pythagorean on right triangles. Since this is not a right triangle, we cannot use Pythagorean. Oh, darn. Man, I wish we could. So instead, what we're going to do is just going to come over here. We're going to do law of sines one more time. But now we're going to solve for side C. So what we should do is, we should definitely pick this fraction here because we're trying to solve for sine C. So I'm going to use sine of angle C over C. And then since we have A over here, I could use this fraction if I wanted to, but remember, we rounded to get side A. So if we want to use this fraction on the left-hand side, we'll be using a rounded answer, which means our final answer for C will also be rounded. Let's not do that. Why don't we use the given that they gave us here? We were given side B and angle B, so that's good. That's like set in stone. So I would match your sine of B over B since it was given. And now let's match it to the sine of C over C since we're solving for side C. Shall we do it? All right, let me erase my work over here. But we're basically taking the exact same steps, folks. All right, so now I'm doing sine, let's do the B over B. So sine of 30 degrees over side B, which is 9, is equal to sine of C, which is 45 degrees, over side C, which is what I'm looking for. All right, first step, remember, we're going to cross multiply. So I'll put the C on the left side so you can just see what it looks like differently. How about C times the sine of 30 is equal to, the other diagonal multiply would be 9 times the sine of 45. Great. As you can notice, C is being multiplied by the sine of 30. That's just a number. So why don't we divide both sides by the sine of 30? And that will get the C all by itself. Great. All right. Sine of 30 is gone. And now I have side C, which is what I'm looking for, is equal to 9 sine of 45 degrees divided by the sine of 30 degrees. All right, let's put that in our calculator, punch it in, boop, beep, boop, beep, boop, beep, boop, beep, boop, and I got about 12.7 to the nearest tenth. All right, see if you got the same thing. So 12.7 goes here. Now we're done. Great job. But we should check. Let's just do a little thing from geometry. Do you remember, folks, from your geometry days, that in any triangle in the world, we know that the largest angle, so example, this angle is the largest angle, is always across from the longest side, always in geometry. And we also learned the vice versa, that, smallest. How about the smallest angle is always across from the shortest side? And you can do the reverse. You can say the shortest side is opposite of the smallest angle. So you should always do with these problems, folks, is just do a quick double check. Is the largest angle across from the longest side is the smallest angle across from the shortest side? So let's do big. Ready? The biggest angle here is the biggest side or longest side is, yay, and they're across from each other. So that's a good sign. How about let's do shortest and smallest. Looks like angle B is my smallest angle. And which side is the smallest? Well, side B. All right. That means there's a very good chance you got this right. And double checking my answers right now, I know that we got our answers right. We did a great job. So that's basically how you do a law of sines problem. Step one again is we made a sketch and we drew the triangle so we could figure out what case do we have. And it's really important we know which case because we're going to figure out, do we need a law of sines, or later when we learn something really cool called the law of cosines, those need different cases. So it's important that you check which case we have here. And then we started organizing our thoughts into an answer box, filled in what we knew, and whenever we needed to find, we went back and used our law of sines formula, just taking one fraction at a time to solve. All right, let's look at one more. How about here on the bottom of the page? This example 2. Can you find the answers to these? So now, what's very interesting, and our college textbook does this as well, because it's very collegey, is they'll use, again, lowercase letters for the sides, but do you notice they're using these sort of Greek alphabet or Greek letters for the angles? Well, don't let that bother you too much. I'm going to switch it up and turn it back into our way using capital letters for the angles. So if I know that side B is over there, that means angle B is over here. Angle A is across from side A. And this Greek letter, which actually stands for sort of the angle C, is angle C. So I'm going to redraw that so I see that better. All right, so let's see if we can solve it. If you feel comfortable and you want to try it on your own, feel free to pause the video right now, and I'll come and join you in just a second. We can check our answers. All right, so we have a sketch already good to go, but let me mark it up based on what we're given here. It looks like I'm given angle A, angle B, and side C right in the middle. What case is that? Those are two angles, and the side there is actually in between the two angles, so I'll write it in between the two angles. Hey, that's an ASA case. ASA case we learned uses the law of sines. Great. All right, let's proceed. So we'll make a little answer box off to the side here. Angle A, angle B, angle C, side A, side B, and side C. Let's fill in what we know. We know that angle A was 80 degrees. We know that angle B was 32 degrees. And we know that side C over here is 17 miles. All right, well, before we start any official law of sines, remember what we did last time is we were able to solve for side C right away by subtracting those two angles from 180. And if I do that, I would get a third angle of, how about 68 degrees? Great. Okay, so that didn't take too much work. Now what we're going to do is we can solve for either side A or side B. And this time I'll do side A just to start. I'm confusing myself. All right, so let me get my calculator ready and let's see how this goes. All right, how about off to the side here? Let me erase some of my work over here so we can see better. Very good. And over here. All right, so let's see what we have. I'll set up my law of sines. Sometimes you can see that as long as we have the sides and the angle across from each other, if we have both numbers, that's going to be the fraction that we're going to use. But I'm just going to write the formula first just so I can see it, just to be sure. But feel free, if you feel comfortable, go and just jump right into law of sines and just remember to use the fraction that has both the letter and the angle that match. All right, there's our original law of sines. And let me check. Again, I know we have both angle C and side C, so I'm definitely going to use that throughout this whole problem. In order to solve for side A, I should use this one here. I should use sine A over A because I have angle A. All right, so I'll set those equal. I have the sine of angle A over side A, which I don't know. And I'll use my red again. Equals, how about the sine of angle C, which we found in our final answers to be 68 degrees, over side C, which is 17. And the first thing we do is we do cross multiply, diagonal multiply, and we get, how about, why don't we move up here? We get 17 times the sine of 80 equals A, the variable we're looking for, the side we're looking for, A times the sine of 68. Great. What's happening to the A? It's being multiplied by the sine of 68. So why don't we just divide that out from both sides? Great. Once I do that, the sine of 68 is gone, and I'm left with just side A. Okay, I'm just about to put this in the calculator. I'm going to type in 17 times the sine of 80 divided by the sine of 68. If I do that right and I punch it in, I get a side A of about 18.05, which I'll round to 18.1. Let's put it over here in our answer box. Looking good. All right, now we're just going to repeat and do it one more time, this time using the fraction in the middle. In order to solve for side B, I'm going to use this one. And again, we want to try to use the given information as our other fraction, just because, like I said, it's set in gold. It's really good. It's not rounded. We should use these two here. All right, make some space, and we'll do one more side. Isn't this fun? All right, so let's set up our fractions here. We have the sine of, now, angle B, which is 32, divided by side B, which we don't know. We'll set that equal to, how about the sine of angle C divided by side C. Oops, we know side C, it's 17. Shall we cross multiply? Let's do it. All right, we get B times the sine of 68 equals 17 times the sine of 32. As we see, the B is being multiplied by the sine of 68. So we'll divide both sides by the sine of 68. And that will free up our B. And we're going to punch this into the calculator right now. Side B is equal to 17 times the sine of 32 degrees divided by the sine of 68. Let me just pause and remind you that on your calculators, make sure you're always in the degree mode because we're playing with angles that have degree measures, not radians. So we always want to be in degree mode when we're in law of sines and law of cosines. All right, I'm punching that in, and it looks like my side B is about 9.7. So I'll put that in my answer box. All right, ready? Shall we do that great geometry check? Okay, let's see. The largest angle, which is A, is it across from the longest side? Well, the longest side is side A, so that's good. How about the smallest? The smallest is angle B, and it is across from the shortest side. So that's a good clue that we did it right. So there you go, folks. So do we always need right triangles to solve? No, we can solve any triangle we want because now we have this amazing, cool formula called the law of sines. We can use it if we ever have an AAA case, AAS case, an ASA case, or the very strange SSA case that we'll solve for another video. Hope that helped and enjoy your law of sines. See you next time.